over this heat sources to connect the heat source and heat sink in a better way of exchanging the heat. Okay, carbon based, metal based, and thermal trees and polymer based trees. Next, active structures and shape memory alloys and electroactive polymers. Shape memory alloys are those alloys. So if you go to Bangalore, NAL is there, National Aeronautics Laboratory. In that National Aeronautics Laboratory, there is a special big section is there which is working on this shape memory alloys. She is working on this shape memory alloys. They are majorly used in this aerospace industry as of now. The applications are very wide. You can use it in most of the day-to-day life activities also. But as the research is in still nascent phase, so major applications nowadays are in aerospace industry. Whenever a vehicle, jet plane or any aeroplane is moving with very high speeds, the surface of that one will face a lot of stresses with related to the air resistance that is offered. And also the structural stability also will face a lot of problem. The shape memory alloys, whatever that are being used, so they will, whenever they are put to such type of conditions, they will adjust their shape in such a way that still they maintain the aerodynamic characteristics. Still they maintain the aerodynamic characteristics. That is what the major advantage with shape memory alloys. Once that particular such abusive conditions are removed, again they will come back to normal shape. Again they will come back to their normal shape. So that is what the major advantage this shape memory alloys means. They will remember their shape. So that is why it is called as shape memory alloys. Whenever you put it into a particular type of situation, they may change their shape. They will respond to that one. But once the conditions are removed, again they will come back to normal position and they are ready to use. Why this is required? Why these shape alloys are required? Why that much research needs to be done on this in this particular area? It should come back to its original shape. It should not be a permanent deformation. That is what the simple words you can say. In simple words you can say, any stress or strain or any pressure or anything you kept, it can be temperature, it can be pressure, or it can be some external force that is acted upon that one. If it is not getting reacted, it will create a permanent damage. If it is getting reacted, that is fine. But at the same time, the reaction should not be permanent. In a simple thing I will say, whenever there is a cyclone, so what will happen? Cyclone in the city or town, if it enters into the city or land, what will happen? And the next day what you will observe? Very big trees are fall down on the ground. And have you ever seen any grass that is fall down because of the cyclone? Why? So if you offer resistance to the force, if your resistance is good, then you can withstand the force. If the force is more than your resistance, you will be damaged. So one thing is, you have to resist with much higher force than the force that is being applied, or you have to adjust to the force. So the big tree will resist, but if the force of the cyclone is more, it will make the tree fall down. But grass will not do that. Even for a small wind, it will bend. Once the wind is gone, again it will come back to original position. Similarly, why the shape memory alloys are majorly used in whenever your vehicle is traveling with hypersonic, supersonic speeds and all these things, the stresses that are acting upon that one, if the structure resists that particular forces, what will happen? It may create a permanent damage to the vehicle. But if the structure will mold itself to according to the forces and go ahead, so it will not damage that particular vehicle. And once the conditions are removed, it will come back to its normal shape. So that is where the shape memory alloys comes into application majorly in aerospace applications. Advanced level of shape memory alloys. So here the shape memory alloys may be related to the structural level. But as I was saying, the Terminator movie The shape memory alloys is with respect to micronuclear level. So they remember the shape and their position at the nucleus level. So that is why the same shape can again brought back. That is next advancement levels we may achieve that one. Right? So even though the body is completely melted out, again it will come back to the same original position. That is much level, higher level of research is required. So majorly the benefits of this one is reduce resilience and always on fans or pumps or adaptive cooling capacity, instantaneous needs, improve aerospace packing efficiency and all. So one example here I'll quote. I visited Srisalem Dam once, the power generation unit. There they said that during the morning time they will generate the electricity. So what happens during the night time? During the morning time everybody will switch off TVs, ACs, fans and all these things, lights, fine. Because there will be sufficient amount of load will be there on the generator unit. Right? But during the night time everybody will switch off everything, only like fans will be running, ACs will be running, everybody will be sleeping. So during that time load will not be there that much on the generator. But still what they do is during the night time small load will be there, not complete, it will not be zero load. It will be little load or partial load you can consider. But if you run the turbine, it will generate the full amount. Suppose a generator is kept about 100 megawatts power. So if the 100 megawatts requirement is there, so if you run the generator, it will provide 100 megawatts and you can supply to that one. But during the night time only 30 megawatts requirement is there. But you have to run the turbine to give that 30 megawatts. So if you run the turbine, it will generate 100 megawatts only. 30 megawatts will be used for the purpose. And the remaining 70 megawatts, you cannot store the electricity. Whenever you require, you have to generate. You cannot store the electricity. Batteries you can store, but that is not that much huge level you cannot store. No transformer. They are only stepping up and stepping down the voltage. Yes, pump back. So what they do is they use that remaining 70 watts power and they will run the pumps and they will pump back the water from the bottom of the dam to the top of the dam again. So the same water can be used again and again to generate the electricity. Not completely, but to some extent we can recover the water. So that is what they are actually doing. In that particular case, there is a limitation. We might have all studied about Kepler turbine and Francis turbine and all these things, and we do velocity compounding and we do pressure compounding and velocity pressure compounding while we are discussing about the steam nozzles and all we have studied. So why we are doing the pressure compounding and velocity compounding? The steam is having the capacity to run the turbine at whatever the RPM that is required. But by doing the pressure compounding and velocity compounding, we are reducing the speed of the turbine. Why? Stresses, right, example, super. Because we do not have the metallurgical knowledge in such a way that whatever the materials that are available, they cannot able to bear that much stresses. If you want to run the turbine with very, very high RPM, 60,000, 50,000 RPM, the material that is used for the blades preparation cannot withstand that much high stresses. So that is why intentionally we are reducing the speed of the turbine by compounding the pressure, by compounding the velocity or pressure, velocity, pressure compounding. We are reducing and we are bringing it down to some 15,000, 20,000 RPM and we are running the system. Here the drawback is we are not having the proper materials to run the turbines at high speeds, though they are capable of generating huge amounts of energy. Right? If you run it, what will happen? The blades will distort and the distortion will be permanent and you have to again reuse them. But there is one more application scope for this smart materials. You can prepare the blades of the turbines by using the shape memory alloys. Even though under these extreme conditions, though they get deformed, once it comes to the normal position, they will again regain to the original shape. So the damage can be controlled in a very great way. So that is where also you can use this shape memory alloys as an application. Okay. Here you can see the same simple example. So when you apply some electricity, so the slave may get distorted. This is a case with the electricity. The condition may be either it can be a force, it can be a stress, it can be a heat, temperature, or whatever it is. Given this simple example shown with the electricity. When you apply the EMF into it, so it will be straight. When you it will be straight without electricity. If you apply that one, it will change. Again, if you switch it off the circuit, again it will come back to normal position. So there are lot many applications with respect to this shape memory alloys. Next one is integration of battery thermal management. Majorly goals are uniform cell temperature, faster heat removal, and abuse and passive statements. As I said, we already discussed this part. Majorly, whatever may be the mode in which you are running the vehicle, the temperature of the battery cell should be maintained at a constant level. Whether it is a normal mode or eco mode or sports mode or ultra sports mode, whatever it may be. So when you run in your vehicle at a sports mode or something else, the draining of the electrons from the battery pack will be very rapid, very rapid. So that rapid draining of the electrons will create huge amount of spike in the heat that is dissipated by the batteries. So this, by using this PCM materials and all, so we have to observe the heat within a short span of time, and we have to continuously keep the material at the required low temperatures. That is what is required. Here this is what you can see. So these are the batteries, and this is the thermal pack around the battery filled with PCM material, filled with phase changing materials. So you will be continuously draining the energy from these batteries. Whenever you start a sports mode or higher usage of battery power, then these battery cells will start heating up. So you have to, this PCM material jacket, this yellow one is the jacket, this blue one are the batteries. So that jacket should absorb the heat from the batteries and maintain the proper temperature. If not, the batteries will get overheated and they will explode. Right? So for better transfer of heat from these batteries to the phase changing materials, so you can use the graphene or nanotube, carbon nanotube material. Because most of the phase changing materials, they are bad conductors of heat. They are the bad conductors of heat, that is the problem. So in order to turn them into good conductors of heat, either you can use these carbon nanoparticles into it along with this PCM materials, or graphene particles into it, and you can enhance their thermal conductivity properties, so that the reaction rate of these PCM materials can be enhanced. Clear? Next, integration with respect to power electronics and motors. As I said, this high heat flux materials and reliable continuous cooling for low thermal resistance and all these things, we need these materials. Majorly direct bonded copper with graphene or thermal interface materials. As we see in the figure, the interface between the sink and source should be proper. If you use this graphene materials or carbon nanotube materials as an interface, the better heat transfer is possible. But only thing is, there is a trade-off. The electrical isolation and electromagnetic interface, packing and serviceability. These interface material having some sensitivity to the this magnetic field and electric fields that are generated in the circuits. So they may disturb their characteristics of heat transfer. So that is one more problem, one small problem associated with them. So if you could able to find out the solution of this interface material to not get reacted for this electric field or magnetic field, the transfer of heat will be much better. Okay. Next, cabin HVAC and rapid optimization. As I said, you can have the air conditioning system for this entire room without having the conventional AC, just by having the PCM tiles. Or during the construction of the house itself, you can use encapsulated PCM materials in your concrete mixer, mix them and construct. So that heat that is generated from the house or outside the house will be taken care by this encapsulated PCM materials, and comfort conditions can be generated. Okay. majorly control and sensing. Yes, till now what we discussed about the materials only. Now the smart part will come into picture. Yes, we have these materials, smart PCM materials are there, electromagnetic, electrochemical, magnetochemical materials, all are there. But how to control them, how to make them more flexible to the operating conditions of the system. So where in this particular place itself the artificial intelligence comes into picture. Okay. Here, one thing I will tell you here is Tesla. Tesla's e-wall, I think e-wall or cyber wall. But Tesla wall, have you heard of this one? Tesla e-wall. It's not in India, but it is majorly popular in US. In India, whether it is morning, evening, or night, wherever it may be, per unit electricity consumption, the rates are fixed, either 5 rupees or 6 rupees or 7 rupees, right or not? But in US, it is not the case.